Hey everyone, welcome to day 2 of Chaos Carnival. Today we have with us Robert Barron from IBM. Robert is an SRE, AI Ops, and Chat Ops evangelist who enjoys helping others solve problems even more than he enjoys solving them himself. With over 20 years of experience in IT development and operations, he is happiest when learning something new. Robert has also spoken at global conferences such as IBM Think and SRECon. Thank you, Robert. Thank you for joining us today.
Thank you. Thank you very much. I'm very happy to be here. I'm going to start with the traditional question of, can you see my screen? And think. Okay, so hello. My name is Robert Barron. I'm from IBM, a medium-sized company working with computers. And what I'd like to talk to you today is about how we are modernizing the way that we manage our mission-critical workload reliability and how we use chaos engineering for that. This is a little bit of a story of a journey that we're going through, and it's a journey that I'm very happy to be a part of. So I can't talk about IBM without talking a little bit about our background and heritage. IBM has been around for more than 100 years, and we've been dealing with computers and computing devices from before there were even computers. So when I talk about IBM and thinking about chaos engineering, I'm actually going to go back. I'm going to go back 50 years ago to the Apollo moon landings. And just this week was the 50th anniversary of Apollo 14, the third successful landing on the moon. And Apollo 14 came after the famous Apollo 13 mission, where an explosion crippled the spacecraft on the way to the moon. And one of the fascinating things about Apollo 13 is not how much the NASA engineers and astronauts had to improvise solutions, but how ready they were for the problems. And the way that they did that was basically by what we would call today chaos engineering. What they called back then were simulations. They practiced for the missions before they launched, and during these practices, they would inject failures and perform what we would call today chaos experiments during game days that would be performed over a period of months. And I'm very proud that IBM's legacy includes the fact that the IBM computers were an essential part of those chaos experiments, which allowed us to get to the moon, because all the information, all the simulated data was preloaded into the IBM computers, broadcast to the astronauts and the engineers during the experiment, because unlike a modern DevOps environment where I can simulate the failure of something in the development environment, we don't have a development moon. We only have the production moon. So they all did all their experiments on the ground using computers to simulate the scenarios. And once they had the results of all these experiments, these were all loaded into the computer to be ready to reuse during a mission if one of the failure modes that they had planned for actually occurred. So while it was not called chaos engineering back then, IBM has been involved with chaos engineering practices, as you can see, for more than half a century. I'm going to fast forward to another partnership that IBM has. Since 1990, we've been working with Wimbledon, being their back-end support during the famous annual tennis match. And as you might imagine, since 1990 to today, the type of services that we give have changed considerably. Back in 1990, it was basically a static website at best. Sorry, in 1990, it was not even a website. It was just IT support. But as the internet started off, it started off with static websites, dynamic websites, mobile applications, injecting AI and other statistical analysis so that we could give more insights to viewers while they were watching. But all through that, we've had to support this website, which is only important for 2 weeks during the year, but during those 2 weeks is critically important and has massive traffic. So that means we do a lot of preparation, a lot of experimentation during that time. And while the actual experiments and the work that we've been doing has changed since 1990, the basic concept of making sure that we have reliability and availability and performance of the system has remained very much the same. So that brings us into IBM today, where we have so many clients, and in so many of them are in highly regulated environments with mission critical applications. And when we come and we talk about the modern way of guaranteeing reliability is actually chaos engineering, their first thought is, wait a minute, we can't be playing games in production. We're not allowed to simulate users performing actions, because every transaction is a financial transaction. It has to be a real transaction. It can't be just a simulation of someone moving money from place to place, because what happens if there's a problem that we didn't expect and someone does lose money along the way? So a lot of the standard attempt of using chaos engineering, especially when we talk about injecting failures in applications, is not really something that is practical or tenable in such a highly complicated environment. And we were getting more and more pushback as we were trying to improve the way that we were guaranteeing this availability. And this pushback comes in many different ways. As IBM does a lot of things for our clients. We are a cloud hyper provider. We've got infrastructure as a service, software as a service, containers as a service, functions as a service, and everyone is using whatever they require. We provide on-premise hardware and software, and we also give managed services. And sometimes the same software is being either used by the client themselves or managed by IBM from end to end, or partially managed by IBM as a service and solution. So now when we try to come up with, okay, how do we do chaos engineering for software X? We now have to consider, is it software X that we're providing as software as a service? Is the client installing it themselves? If they're installing it themselves, are we managing it for them? So there are so many combinations of how we can do chaos engineering, and this changes whether we are providing software, providing services, providing a mixture of the two, what sort of contract we have with the client. Sometimes we have contracts that are specific contracts of we're going to do X, Y, Z, and sometimes there are contracts which are more open-ended. For a period of 3 years, we're going to supply you with managed services for whatever you require. So again, how does chaos engineering look in this way? Do we have to supply 4 different flavors? Do we try to have one flavor that is unified? And of course, these things have to be cross-checked with the various industries that we work with. Many of them are very highly regulated. Sometimes we have clients who are completely air-gapped, so it's updating a new version of something is not as simple as downloading it, a new container and restarting the pod so it picks up the new container. But you can only insert new things once every 3 months, once every or something like that, and you can't integrate between tools. A major part of the problem is also the fact of technical debt. The systems that were used to launch Apollo to the moon are no longer in existence, but there are still applications that are 20 years old that we are dealing with, that we support, that we still want to be part of the environment that we are managing, and we have to do chaos experiments on these old monoliths, which they might be monoliths, they might be old, we might not understand exactly how they work, but they're an essential part of the application. And we need to include them in all our planning. And of course, the idea of culture and skills. We have people who have for 20, 30 years have been thinking, We need to keep things as steady and stable and well known as possible. And the whole idea of doing random experiments is anathema to them. Give me the mathematics of the engineering. Give me all the details where we come in chaos engineering and we're saying, look, we're not going to pre-plan exactly how the experiment is going to go along. We're going to expect some surprises along the way as to how the experiment goes. If we do the same experiment again and again exactly the same way, we're not going to be learning new things. So these are all changes, all challenges to how IBM works and how IBM can modernize the reliability and availability that it guarantees its clients. The only thing that we do know, of course, is that things are going to break, and we need to have plans to avoid this breakage and to have contingency plans to solve it. One of my partners, Hatham, is one of the first chaos commanders in IBM, has a saying that applications must mitigate the 5 Fs: fires, floods, fools, and fat fingers. And I'm just a fan of alliteration, so I love this. I love the sentence and I use it as much as possible. But fires are problems that come in from within the data center, within the application. It might be a physical problem, like something going up in flames, or it might be a bug in the application, or it might be a configuration that used to be good, but now because other things have changed externally, is no longer suitable. Floods are external things, like a flood that comes from outside the room and washes away the computer, or it might be bad data that is being injected in through a queue or through a webhook into the application. It might be a denial of service attack or anything like that. Fools are the people who do not follow the routines that we are putting in place, do not work as modern SREs are supposed to, or developers who still want to manually deploy things into production. And fat fingers are people who do know what they're supposed to be doing, but simply made a mistake. If you have enough years experience in any job, you'll have made mistakes. If you haven't made mistakes, then you haven't tried enough and you haven't done enough and you haven't experimented enough. But we've got to make sure that our applications can survive any of these problems, whether they're internal problems, external problems, people doing foolish things, or people just making honest mistakes. So because this problem affects or is relevant to everything in IBM, and IBM is 350,000 people across many business units and domains, and each business unit has different responsibilities and different requirements and is measured in a different way. It's often very difficult to get people to agree on a plan of action. So that's why we have within IBM a group called the Ibm Academy of Technology, which is a group that crosses across all the business units and all the geographies of IBM. We've got 700 members. We're aggregated into geographic areas to a certain extent just for convenience's sake. But what we do is we create projects which are of interest across IBM, and these projects can vary from we've got this new AI capability, what are we going to do with it? We've got this new financial algorithm, which clients would be best served by it. We want to start using this new process inside. What's the best way to roll it out across IBM? And in this case, what we did was we said, okay, what is the best way for IBM to start adopting chaos engineering across all its business units in a reasonably unified manner, which will allow us to have our unified concepts, which will be globally accepted within IBM, but allow each business unit depending on whether they're developing applications or giving services to clients, be able to adapt it to the requirements that they have. So within the academy, as I said, we have 700 full members. We have nearly 20,000 volunteers in addition to the full members who participate in these initiatives, scattered across 6 of the 7 continents in the world. We couldn't convince someone to relocate permanently to Antarctica, but we'll have to accept that we get most of the continents in the world. So what we did was we set up an initiative. We had about 50 people working on it. The B represents the people, the IBMers working on the initiative around the world. And what I'm going to be presenting to you here is our basic results of the initiative. So before starting the initiative, we just defined some stepping stones as what do we want to achieve with chaos engineering. We want to add visibility to our systems. We want to reduce the risk of our systems, and we want to be able to test for failures more easily. And again, this doesn't matter if I'm developing new software. I want to be able to put the visibility into the software, reduce the risk of anyone using it, and I want to be able to test for failures for it. Or if I'm delivering a service to a client, taking this software as a black box and deploying it, I still need these 3 stepping stones in order to succeed. So I'm not going to go into all the details of our work because they'll just be boring for you. That's showing you the less interesting part of the sausage making, but I do want to tell you about some of our results. So we started off with general principles of chaos engineering. And if you're familiar with chaos engineering, these principles will be quite familiar to you, but for many of them, we have our own IBM spin on things. So strengthen reliability disciplines, because we're not starting from scratch. We're starting off with an environment. In nearly all cases, our clients have systems that they're already doing tests on them, they're already working on them, they already have reliability disciplines. We don't have any green fields. So we're not creating reliability disciplines, but we're strengthening what exists. And if we don't have good reliability disciplines, then this sub-organization in IBM is simply too immature for chaos engineering, and we need to start getting them just the basic discipline of reliability before we can add the layer of chaos engineering. Understanding the system. And again, the systems in IBM are usually very complicated. They're usually complex and are across multiple technological domains. And you need to be able to understand both the makeup of the system and the interfaces that they have. And that leads us to making sure that we experiment on every component and don't silo things off and say, okay, this belongs to Network Bob, so we're not going to experiment on this because Bob is in a different department. But we're going to say, no, we're looking at the system, and it doesn't matter the organizational department that the different responsible people are. We're going to experiment on every single component. And we're going to strive for production. And I say strive for production because we know that there are going to be cases where we simply will not get to production for contractual reasons, regulatory reasons, complexity reasons, or simply perhaps risk reasons. We will need to be conscious of the fact that maybe we won't be able to understand the system well enough in production in order to execute a safe experiment on it. So, or we're never going to get regulatory approval to do so. So it's not that we're going to say, no, okay, we can't get to production, so there's no point in doing this, but we're going to work as if we were going to be ready for production. And we're going to test in development and not half-heartedly test because development doesn't really represent production. But we're going to say, okay, we can't test in production, so maybe we'll upgrade the development environment so it will be good enough for production. Or we're going to not really test in production by running actual technical experiments, but we're still going to do the cultural side of game days and pretend that things have crashed and see whether people know how to find the relevant run book or the relevant procedure to solve the problem. But we have to be absolutely sure that we know how to contain the impact of the system, because, as I said, so many of these things are very, very so much regulatory and financial meaning if there's a problem with the system, if something unexpected happens that our chaos experiment gets out of control. We need to measure and learn and improve as we go along. There's no point in doing a chaos experiment if the only thing we learn is whether the system was up or down, but we need to add as part of the experiment measuring what the performance what performance metrics we're looking at, and we need to know, okay, we've seen the result of the experiment, how can we make this better the next time? And again, these are not binary things of working, not working, but making sure that they improve. Then we need to start increase complexity gradually. And again, sometimes, often we'll find that we'll come up against some sort of barrier, a technical barrier. For example, we're in the distributed environment and suddenly we reach a queue, and on the other side of the queue is a mainframe. So here, one little step is going to take us from the world that we're familiar with into the mainframe world. And of course, it goes the other way. It goes in the other direction. Mainframe people are suddenly stepping out into the open world, working together, maybe going into the public, going into clouds. So we need to be able to manage the fact that we are increasing our complexity while we're still understanding the system, while we're still covering every component that we're working on. And very, 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 very important is to socialize continuously, to make sure that everyone knows, from the most important stakeholder, the executive is responsible for the system, down to the people who are in the trenches doing the operations or development work, to understand what we're doing with chaos engineering, why we're performing these experiments in this way, what results we expect to get, and what action items we want to get out of the successful chaos experiment. Because a lot of times people will say, well, I don't want to do this experiment because it's just going to end up with more work for me, and I'm very comfortable with the situation as it is today. Thank you very much. So we need to socialize always the benefits, convince people all the time of the benefits of chaos engineering. So once we set out with our principles, which are our guiding light, our North Star to how things should work, we went, okay, let's go a little more technically into the methodology of how it's actually going to work. And we came up with a wheel, a process wheel for our methodology. And some of these components of the wheel are going to be very similar to the principles, and some of them are going to be things that become obvious because of the principles. So we start off with understanding the system end to end, and then we have a number of checkpoints and checklists that we do, like breaking the solutions into the layers, components, and topology, understanding the reliability of each component and each layer individually and as a group. And part of this learning is reviewing previous outages and postmortems and so on. And then you can suddenly get to the position where you say, wait a minute, this organization has not been doing outages, has not been doing postmortems properly. They have an outage, they have a problem, they solve it, but there's never a postmortem. We never learn anything about this. So this can be a good trigger to get them to start working on postmortems and understand them. So we'll leverage, we want to achieve chaos engineering, but there are a lot of steps along the way where we're going to be strengthening the rest of our engineering capabilities and engineering requirements as a prerequisite for that. For example, existing monitoring. And often we come to an organization where simply you cannot do an experiment because so much of the system is in the dark and you don't have monitoring of the components. So we need to say, okay, as a prerequisite, we need to start doing postmortems, identifying weak points, improving the monitoring, and then we create a backlog. And then our first chaos experiments might not be actual experiments on the application, but experiments on understanding the system. We're going to have a chaos experiment on the monitoring. If we change something in the monitoring, are we going to actually notice that we changed it? And a post-mortem can be a game day just around post-mortems, doing mock post-mortems as a prelude to doing actual chaos engineering. So not everything needs to be a technical experiment. Then we have the organizational agreement that we need to achieve. And again, often we have stakeholders who, for them, you say the word chaos, and they say, no, I don't want this randomness stuff. I want to know what's going on in my system. There's a great deal of emotional an emotional response to chaos engineering. Personally, I'm of the belief that chaos engineering is doing itself a bit of a disservice with the emphasis on randomly restarting servers and components, because it's not really the technical procedure might be random, but there's nothing random in everything leading up to that work, and we need to anticipate these objections and make sure that we're giving confidence to the stakeholders that we are going in the direction that they want to go, and that the end result is not going to be random downtime, but it's going to be improvement of SLOs and error budgets. And it's very, very important for us to be able to highlight a track record of safety and success in performing chaos experiments, whether it's with a specific account or just coming with our track record in other accounts saying, we did this for client XYZ, we can help you with this, or even showing when we develop our software, what sort of chaos experiments we've done during the development and how it has helped us develop a better software. So then once we understand the system, we know what we want to do, we've got an organizational agreement to do it, we start with the next steps, which are the more traditional chaos engineering steps of creating a hypothesis, planning the experiments, enabling observability in the system. And again, often we see that when we have mixed systems, some of them are very modern, some are less modern, some are very transaction oriented, some are very database oriented. It's sometimes quite difficult to get good observability end to end. Then we prepare the experiment, and we have various checklists of how to prepare the experiment depending on the requirements of your specific organization. Running the chaos experiment, and again, I like very much to do game day activities, which have nothing to do with the technical, with the code itself. When I start off as consulting with a client of how they can do chaos engineering, I'll do a game day, which is completely imaginary. And just by doing this sort of imaginary game day, we can see a lot of gaps in, wait a minute, we had a problem, who needs to deal with this? Do we even know who we need to escalate to? And if this problem happens, do we know what the procedure is? And do we know how to find the relevant documentation? So I love doing chaos experiments that are imaginary. Analyzing the results, proving or disproving our hypothesis. Often we'll find out that the test succeeded, but it didn't prove or disprove our hypothesis for some reason, because something else happened during the experiment that we were not aware of. And that's, to my mind, that's the best kind of experiment sometimes, because it shows us the gaps in our knowledge. So then we either need to change something in our understanding of the system or add new monitoring, or just modify the test to make sure that it is more precise and will show us what we require. And then, of course, communicating our findings. Publishing. It's not enough to do a chaos experiment and then document it and put the various action items in your backlog. You need to publish it. And the publication of a chaos experiment is something that will both raise the morale of the people who are publishing, and it will create interest in the people who are reading this. And suddenly they'll see, wait a minute, people are doing interesting things around engineering in the organization, and they're getting better performance, they're getting better reliability, and why can't I do the same thing? So we have this is a synergy and a self-fulfilling prophecy. The more you publish your successes, and this is true for any effort that you make to try to improve the culture of an organization, the more you publish your successes, the more interest you get, the more other people try to replicate your successes, and so the more successful you'll become, because the wider the scope you have for your chaos engineering, the more you break down the silos between organizations, the easier it will be to perform more experiments and to get more buy-in by other organizations. And of course, we can also communicate that we failed for a specific reason, and then we can then we go back, prepare the experiment again. Maybe we need help from a different organization. Maybe we need support from a different engineering team, and we try again, and then until we succeed. Once we've succeeded, we're going to start growing the blast radius and repeating. One success leads to another success, leads to a larger success. And then this goes back into helping us gain organizational agreement, because we've proven that we can do chaos experiments. We've proven that we can learn from these chaos experiments. We've proven that there's benefit from chaos experiments. So we can now expand even more throughout the organization. And then when we expand, we will expand to production. Doesn't necessarily mean the production environment. It can be expand to just the next level. It can be expand to another application, a more sensitive application, and so on. It can also mean expanding into beyond just the engineering, the site reliability engineers doing chaos engineering, but also as part of the development team, adding chaos engineering as part of the pipeline, delivery pipeline, adding an autopilot whenever you deploy something new. Part of the testing is an automated chaos engineering routine, an automated experiment every time you click merge of something into your pipeline. And of course, this is all cyclic. It's cyclic within a specific part of the organization, and it's cyclic and constantly expanding into other parts of the organization. So just to recap to a certain extent, we have our principles of chaos engineering, which are universal. They are very much in line with principles of chaos engineering that you'll find documented everywhere on the internet, but some of them, especially things like strength and reliability disciplines, strive for production, socialize continuously to a certain extent, have additional nuances in an organization like IBM, which is such a hybrid, such hybrid solutions that we need to support. And if I summarize it in one sentence, it's that to succeed, we need to present chaos engineering not as chaos engineering, but as a mature and rigorous engineering method. That's where I find that the emphasis needs to be on the engineering side of things. That gets much more cooperation and collaboration, because you're justifying it with the numbers of what you're doing. I have a couple of links here, which I'll share in the channel in a moment. We've published a lot of these things within the IBM architecture site, the principles of chaos engineering that we have here, a little more detail than I've gone into in the session. I've also write a blog where I started off with lessons from the Apollo missions relevant to chaos engineering, and I believe that there are many other chaos engineering specific lessons in chaos engineering, site reliability engineering, availability from Apollo. So I have a series of blog articles that I've written on the subject. Thank you very much. You've been a great audience, I'm sure. And I'd like to open it up to questions now. I will stop sharing so that I can see the questions in the chat.
Yeah, let me read that out for you.
Yes.
So Prithvi has a question. What are the possible points to keep in mind to inculcate the idea of a cultural shift necessary for organization to adopt chaos engineering?
Sorry, come again, please?
What are the possible points to keep in mind to inculcate the idea of a cultural shift necessary for an organization to adopt chaos engineering?
Okay. So the first thing is to find the need, the necessity. And if we were still developing applications the way we were 15 years ago, then maybe we wouldn't need chaos engineering at all, because things would be steady enough and static enough and would not be changing the way they are. So I'd go and find an organization that is suffering. Often it's going to be the development organization that is coming in and saying, I've started developing in this new way. I want to deploy all the time. I have microservices, but the operations people are saying, I don't know how to handle this. This is changing too much. This is too risky. I'm not going to allow you to deploy so fast. And then you can come in the middle and say, well, chaos engineering can bridge the gap between development and operations by giving operations confidence that no matter what development are doing in their systems, operations will be able to support them, because we've done these game days which have shown operations the way. So what I would try to do, for example, is just to isolate some people from development, some people from operations, and do a game day in the development environment. And often you'll find that this will lead to other benefits, like the operations people will suddenly realize that development have no monitoring solutions, or have different monitoring solutions than they have in production. And that's why there's such a big gap, because what developers are saying, yes, of course I've got observability, I can see this exact detail. And the ops guys will say, no, I don't have that tool, I have no idea, I know nothing. And as soon as they do a game day together, then they'll suddenly appreciate what each other is trying to handle. And the game day one of the action items in the game day will always be, okay, let's get more alignment between the two teams. And that's going to be your first success. Someone in development is going to say, yes, I want to do this, not for me, but for my friend in operations. And that's how you can start getting more buy-in. You'll be getting success, and they'll get more buy-in with stakeholders.
So a follow up on that. So across different industries, different companies would be at different levels of evolution, both in terms of their development process and also their operations, right? So
yes.
What would be the when you're trying to push chaos engineering, should you be like pushing chaos engineering itself, like we need to do chaos engineering, so
no, I would not push chaos engineering per se. Mm-hmm. I would push, say, DevOps or site reliability engineering, and chaos engineering would be one of the tools that I use for that. The chaos engineering is not I don't want to do it for chaos engineering. I want to do chaos engineering for something. So let's find that something. Let's find the gap that chaos engineering can fill. And as I said, if you don't have monitoring, you can't do chaos engineering, because you'll do your experiment and you have no idea whether it succeeded or failed. If you have no communication between silos, then your experiment is going to be very, very small. So start working on that. And yes, I think I love game days, which are not which are just theoretical, mind games, because then you can do it with no risk. So everyone will easily agree, yes, it's just going to cost me half a day, and we're going to have donuts in the morning, and we're going to have lunch together, and we'll do a chaos experiment. And they have no idea how much they're going to learn just by doing a simulated imaginary chaos experiment. And once they don't have anything to learn from there, then you don't have to convince them about the value of doing a technological chaos experiment, because they have already bought into the concept and they want to do it.
Another question from Kale. What would be the appropriate KPI for chaos engineering, the process and the practice itself?
So I would say I don't like this, but for chaos engineering itself, I would say that it's NPS. I don't remember what the acronym is at the moment, but it's how satisfied you are with chaos engineering. If someone came to you and said, "Do you like chaos engineering? Would you recommend it to others?" If you say yes, that's the metric for chaos engineering.
Oh, like Net Promoter Score.
Exactly, Net Promoter Score. Because everything else is not what chaos engineering is, but what chaos engineering does. If I'm going to take, let's say, availability, so I do a chaos experiment and I discover that I need to change my monitoring. So who gets the glory? Chaos engineering or the monitoring? Because actually I changed the monitoring. Chaos engineering didn't improve my reliability at all. It was the monitoring that I improved thanks to chaos engineering. So I find it very difficult to put my finger down and say, chaos engineering did this, chaos engineering did that, because I'm trying to improve engineering across the board. I'm trying to improve the collaboration between teams, the engineering rigor of teams, deploying new tools to help them. So what of that actually made the difference? I don't know. But if I use Net Promoter Score, people will say, yes, we only did that because of chaos engineering.
So there was a question from Michael. For scenarios where running experiment in production is not possible, what would you recommend to start the process of chaos engineering on a non-production system?
So in that case, I would go backwards. I would say, let's start in development or and then go as close to production as possible. And then let's start going backwards and make that environment closer and closer to the level of production. If I can't get to production, I can't get to production. Let's bring production to me as much as possible.
Okay, the next question. How do you ensure blameless collaboration between teams while applying chaos engineering through layers and teams?
So that's part of the adoption that teams, that organizations have to get through. You show them the benefit of blameless. And by the way, again, game days are an excellent way of doing this, because in a game day, no one is really to blame, because we've injected the failure ahead of time. So there's no ego and there's no covering yourself and hiding and so on. But then you start getting into the habit of doing blameless. So if you do a blameless game day, a blameless game day, a blameless game day, a real post-mortem, well, suddenly you're used to the fact that it's blameless. So why should the post-mortem go back to the old way of being finger pointing?
We'll take one more question. Another one from Dudu. Did you automate and include to the CI/CD cycle the learned previous experiment as tests?
So I can't answer. That's a good idea. I can't answer that we did it because Gabriel, excuse me, I've had a chaos experiment here in the background myself. It's a good idea, but yeah, IBM, we've got hundreds of teams. I'm not explicitly aware of a team that has done that, but it's certainly part of the recommendations that we make for teams to aspire to.
All right, Robert. I think we are on time.
Okay. I see. I'm just looking. Yes. I'm sorry. I'm not sure how to pronounce your name, but Jürgen Herman says continuous resiliency testing instead of chaos engineering. Yes, you find the words that match what people want to hear instead of chaos engineering sometimes. Yes. Okay. So thank you very much.
Thank you, Robert. Thank you for joining.
It was my pleasure.
Let me end the session.